So yeah, I'm gonna talk about generating patterns. I'm gonna kind of loosely follow these notes, and I'm gonna do a couple different demos just to kind of go over different ways of thinking about this stuff. So there isn't like one specific approach that's you have to do, but I'll cover a couple different ways to approach creating a pattern. Um, I'm going to start with something that just kind of goes over some of the basics and create a more kind of abstract pattern. So I'll call this nested for loop pattern example. Um, and then I'll do one that's a little bit more representational and talk about the approach for that. So this is going to be just kind of an abstract pattern. So nested for loop abstract pattern. I'll put the date for today in my comment. And so I'm going to kind of get started like I did last class, talking about how I'm going to divide up my grid and just kind of reviewing, thinking about the space of the canvas and creating a grid. So I'll do that, and then after that, I'm going to add in some variations using a couple different approaches inside of my for loop. So to start, I don't know if I've talked about this, but I kind of want to make my canvas space a little bit bigger. So for my width and height, I'm going to use inner width and inner height, or wait, window width. I always forget. Window width and window height. This will actually fit my canvas to the available space. I feel like I actually haven't talked about this before, which is weird because I usually go over it. But it's pretty useful if you want your canvas to just fit whatever the basic space is. That way you don't have to like think about making it 400 by 400 or 600 by 600 or whatever. You can just use window width and window height to fill up the space, and that could be cool for creating your pattern. So I'm going to start with that. And so when I'm creating a grid pattern, I want to think about columns and rows. So columns are the horizontal spaces, and rows are the vertical spaces. And if I use just kind of like simple math here, I can avoid like actually doing a lot of the specific calculations. So I'm going to start like I did before I get started, let's go ahead and change our draw function to the pattern function and put that in setup, so that way we don't have to worry about the draw function looping. We'll just draw one version of our pattern. So yeah, first I want to start with just the number of rows and columns that I want. So I'm going to say variable calls for columns, and I'll start with something simple. I'll do 8 columns. And the variable rows is, let's also do 8. We can obviously change this. So then we just have to use the space of our canvas to figure out how big the width and height of each column and row should be. And so I'm going to use a shorthand variable w, and that's going to be the width of the canvas divided by the number of columns. So that tells me, when I divide the whole canvas by the number of columns I want, that tells me how big each individual column is going to be. And I'll just say width of column. And then I'm going to have a variable h, same thing but for rows. So the height of the canvas divided by the number of rows that I want. So using these variables, I can change the number of columns and rows and not have to think about like, is it 50 pixels? Is it 55 pixels? Like doing math in my head. This way the program will do the math for me. So then we can set up our grid. So we're going to start with for let x equals 0. And we'll do x is less than width. So we'll go all the way across the canvas. And we'll say x plus equals w for the width of our column. So that's going to fill up all the columns. across the canvas. And then we add our nested for loop for let y equals 0, y is less than height, y plus equals h, or the height of one row. And so now let's just start simple. I'm just going to draw a rectangle here. So I'm going to do a rect, and I'm going to put it at x and y, and I'm going to use the width and the height of my column and my row. And when I run that, we get a nice little grid because I still have the stroke turned on. So again, all of this stuff is all based on these numbers right here. So if I change the number of columns to 6, my grid updates, or if I change the number of rows to 4, my grid updates. So by kind of like figuring out those structures and using the program to do the calculation instead of having to think about it in my head, I can create this nice simple grid without having to really think about how to do it mathematically. So I've got my grid, so I can think of each one of these cells as a different part of my pattern, and this is where I can start to add in some different variations. And we can also think about starting to divide up the space a little bit. So actually, I want to increase my grid a little bit. I'm going to do 16 by 16, so we have a little bit more to work with. And let's talk about some of the different variations that we can do here. So let's make a custom function just to review that real quick. So we have this nice bit of code that sets up our pattern. And we can add another function to actually do each individual block of our pattern so that we don't have to worry about reading through this big for loop, this nested for loop. It gets kind of complicated. So instead of doing a rectangle here, let's create our own function. So I'm going to go below the pattern function and do another function. And let's just call this function, I don't actually know what I'm drawing yet, so let's just call this function cell, as in like a cell in a grid. And we'll put in our x, y, w, and h. And then I'm just going to take this rectangle, and actually I don't even have to remove it. I'm just going to copy it, put it in here, change the rectangle to cell. And now I'm going to delete these extra spaces. And so now this looks exactly the same, but now I have a separate function where I don't have to even like look at all this stuff. I can collapse my pattern function and just focus on my cell function. So it doesn't really change the functionality a lot, but if I have a lot of different functions doing different things, this is really going to help me organize my code a lot more. So now we have this little function for our cell. Let's add some variations in here. So there's a few different types of variations that we can do. So I want to kind of talk about those and do some examples. So one thing that we did on Monday, a simple variation, is just doing randomized colors. So the way that we did that is I made a new variable for red and randomized that, set it to some random number between 0 and 255. Same thing with green. Same thing with blue. And then we have to actually apply the colors. So we can say fill R, G, and B. So we get some new colors. Let's turn off the stroke. So now every time I run this pattern, we get some new colors. So that's pretty cool, but we might want to kind of change the colors a little bit. So we might want to create like a constrained color palette. So we could think about, a couple different ways of thinking about it. But I also want to think about what am I trying to kind of represent. So even though this is abstract, I might want to keep in mind like a kind of like idea of what I want to draw. So as a really simple example, I'm just going to draw kind of a landscape. And so for my landscape, I want to have the bottom area of the canvas be more green and I want to have the top area of the canvas be more blue. So I'm actually going to change these values depending on where this y value is, right? So if y is 0 up here, I'm playing with these rectangles up here. And if y is like really high down here, we can know where we are in the canvas. So we can adjust our values based on that. So this is a little bit more tricky, but we can initialize our variables first, r, g, and b. And then we can say if y, so remember our condition, so we can ask where our y value is. So let's see if y is greater than, I don't want to do it directly in the middle, but let's do it at 2/3. So I'll say height, that's the height of the canvas, times 2/3. So anytime the y value is greater than 2/3 of the canvas, then we want to create a green color. And otherwise, we want a blue color for the sky. So I'm going to delete these vars. And the reason I'm doing this like this is when I want a variable that could be one thing or another, one way to deal with that is to declare my variables first, just say that they exist, and then to assign them later. So that way my program's not going to get confused about what variables I want to have. But if I declare my variables again inside of these if statements, then they won't be the same ones that I used before. So when I have like a choice like this, I need to say like what is the output's going to be first, and then depending on the choice, if y is greater than the height, then we're going to assign one set of color values, and if it's not, we're going to assign a different set of color values. So that's why I'm going to have these two different sets of my colors, and I'm going to declare these variables first. There's a lot of different ways to do this, but this is kind of a simple way to do it. So then I'll delete these guys. And so then I'm going to change my color ranges to change the output a little bit. So if I'm creating something that's green, I don't need as much red. So let's constrain the red. Let's say the highest value is like 150. I obviously want more green for a green color. So I'm going to put a smaller minimum or a larger minimum. So I'll say like maybe 200. That might be too much, but we can say for the green, we'll have somewhere between 200 and 255. So there's going to be more green. And then for my blue, for green, I need a little bit of blue, but not as much. So let's set the max there at 200. And we can see how that looks. So you can see that now that bottom 2/3 of my canvas is a lot more green than it is red or blue. So let's do that for the sky, and then we'll do a couple more adjustments. So for the sky, I don't really need that much red if I want it to be mostly blue. So let's try like 100 for the red. Don't need as much green, but I might want a little bit of green. So I'll do 150 for green. And then obviously we want a lot of blue, so I'll put 200 for the blue to 255. Okay, so that's pretty good. Now we have like a really blue sky. It's a little bit on the darker side, so I might want to raise the values of my red and green a bit because I'm still mixing the colors together. So if I have like 0 red and 0 green, I'm going to have a darker blue. So if I raise the floor for this a little bit for like red, if I do like 50 to 150, they're kind of more purple now, but you can see they're lighter in general. So same with the green, I'll do like 50 to 150. So now we have generally lighter colors, but there's a little bit more purple. So maybe I'll just do 100. There we go. So for the red, so we get more just kind of blue values. And our grass is a little bit too blue, so let's bring the blue down for the grass. Maybe even more. So that's a simple way to kind of change the spatial aspect of my pattern. So I'm using a combination of different things here. One is this if statement to separate these two different conditions, the top versus the bottom of the canvas. And that's just one example. You could do, right and left, or you could do different quadrants. And then the other variation I'm doing is just basic randomness using random colors. So another thing, I'll do a couple more simple variations. One thing I don't really want to do is change my actual variables. So if I say something like x plus equals random 50, this is going to kind of mess up. It still kind of works, but it's going to kind of mess up the way the grid works. So what I can do instead is just add it directly into my rectangle. If I want to vary the position a little bit, I can say x plus random, maybe like negative 10 to 10. And that'll kind of add a little bit of variation to the positions of my shapes. And, maybe I like that. Maybe I want it to be more on the y side of things, so I could move this over to the y. So that gives me some kind of different variations. And now I'm kind of like seeing through the pattern, so I might want to put like a color behind it. So I could, make another rectangle or something with a different color to put behind it if I wanted to. You can add more stuff in there if you need to. Like the whole background? Yeah, I could put a background like I could change the actual background. Like if I wanted it to be mostly blue, I could change the actual background to light blue. Yeah. Yeah, I can, well, I can't change, yeah, for the background function, it can only be one color. But what I could do is draw a rectangle. So I could say like, I could use the same condition, or really I could just draw a rectangle. So I could say like, fill green rectangle, 0 for x, height times 2/3 for y, go all the way across to width, and it doesn't really matter how far I go down because it's going to overlap the bottom of the canvas. But yeah, so I could add a rectangle as part of the background. Yeah, so that looks a little bit better because it matches what's going on in there. So I could also use randomness to make choices. So one thing I can do is, let's say I wanted to have random widths. So I could say like variable underscore w. Sometimes I use an underscore if I want to use another variable that has the same name, but I don't want to overwrite the first variable. Oh, I was going to do this with the y first. So one thing that you might want to do, if you have something like this, like y plus random, this is fine. There's no reason not to write it like this, but if you want to make it its own variable so it's a little easier to read, that's something you can do. You just make another variable. So what I usually do is what I just said, I'll say like variable y underscore. Sometimes people use this or this when they just want to have another variable with the same name. So I'll say y plus random negative 10 to 10. And then I can put the underscore y in here. And so that won't mess up my regular y, but I still get the same variation. So then the next thing I was going to do is vary the width. So I could say like variable width equals w plus random, maybe like negative w to w. So it'll be like a pretty wide range of different widths. And then put underscore width in here. So you're getting a lot of different widths there. But we could also, choose when to do that using a random choice. So that's another thing that you can kind of do randomly. Actually, let's use a different shape for this because that'll be a better example. So I could randomly, so right now I'm always drawing a rectangle, but I could randomly choose a different shape. So I could say something like if, well, let's make a variable for this. So let's say variable r equals random 2, and then let's floor that value so we know it's going to be a whole number. So this will either be 0 or 1. So random 2 is going to give us a value between 0 and 2, but not up to 2. And so if we floor that, we cut off the decimal point. So we know it's either going to be 0 or 1. So then we can say if r equals 0, we'll draw this rectangle. So it's going to have a 50% chance of being a rectangle. Shoot, I lost my arguments. X underscore Y underscore W height. So yeah, actually now it has like a 50% chance of even existing, which could be cool. Or we could draw it in ellipse, X underscore Y underscore W and height. The ellipse is going to be offset because we're using, I haven't changed the rect mode. So it's going to look a little weird, but what we could do is either offset it using our parameters, like I could say minus W over 2 for X and minus height over 2 for Y. And you can't even really tell the difference because there's more variations going on. Also, you know, in this context, it probably makes more sense to have my ellipses happen, you know, up here in the sky and have my rectangles happen down there on the ground. That might make more sense. Like it would look like clouds and grass or something like that. But that's just another example. And then I can also make other choices. It doesn't have to just be 0 or 1. If I did like random 3 here, it would be 0, 1, or 2. And so now I could say, you know, if r equals 0, else if r equals 1. And then have the ellipse be the last one. So else if r equals 1, what's another shape that we can draw? Blanking on my shapes. P5 shapes. I guess those are kind of the main shapes. I could draw a triangle. Okay, let's draw a triangle. So I have a triangle. We'll start at x underscore y. We'll go to x plus w, y plus height. And then we need a third point. Let's just do x plus, I'll just do some random stuff. Random width underscore width and y plus random underscore, or I just have h for this one. Okay, the triangles kind of suck, but you get the idea. I can do different variations. So this is looking a little too chaotic. So let's take out some of these. Let's remove a little bit of the randomness. Maybe, I guess because I'm changing the y and the width, it kind of like looks weird. Let's maybe leave out the width for now. So I'm just going to comment out the end of this line so I don't have to rewrite this whole thing. Okay, so that looks a little bit more interesting. So, you know, throwing lots and lots of randomness is just going to make it more chaotic. That might not necessarily be good, but it could be kind of cool. And you can obviously, like, you know, try different stuff and then remove it if it doesn't really look good and just play around with different ideas. And let's see what this looks like if I really change, like if I do a lot of columns and rows, like 32 by 32. Looks kind of interesting versus if I just do a few like 8 by 8. also kind of a different vibe. So there's a few different ways that you can view that. I could also randomize the number of columns. Like I could say random, let's do floor random 32, floor random 32. So now we get a lot of different types of variations. So there's a lot of different outputs. Cool. So I think that kind of goes over some of the basics. I wanted to do one more thing. It's a little, I think I can do this quickly. So I wanted to do another one where I'm doing like a more complicated loop setup just to kind of show how something like that would work. So, and how you would, going beyond just doing one nested loop to actually doing a nested loop within another loop. And then another loop in that. Let's see how far we get, but I'll try to do it quickly. So I'm going to go to a new window. And so this one, I'm going to do something specific and representational. That's the other thing I wanted to do. So I'm going to call this pattern representational. And a project that I used to do a lot was like a generative city landscape. So let's do that real quick, and I'll try to make it relatively fast. Okay, so for this one, I'm going to do kind of a similar thing, but first I'm going to generate the buildings, and then I'm going to generate the windows in the building. So everything will be randomized, but it'll be kind of structured, so it actually looks like something. So to start, I'm going to have a loop just going across my canvas. Let's do like a longer canvas. Let's do like 600 by 300. And I'm going to have a loop going across the canvas just drawing buildings with random dimensions. So let's pick a number of buildings that I want. I'm going to do the same thing where I'm going to call this a pattern and change my draw function to pattern. So I'm going to pick a number of buildings. A lot of time I'll say something like this, variable num buildings, to represent how many buildings I want. So let's say we want 5 buildings to start. And then I'll just create a loop based on that number. So I'll say for let x equals 0, x is less than num buildings. And then we need to calculate the width of the building. Actually, let's do this. Let's do a different type of for loop. So I'll say let I equal 0. So I'm just going to count here. I is less than the number of buildings. And we'll just count up by 1. And then we can just calculate x based on that number. So we'll say let x equals I times num, or let's get the width first. That'll be easier. So w is going to be the width of the canvas divided by the number of buildings. Oops. It's hard to spell buildings. And then x can be based on that. So x is I times w. And so this might be a little confusing, but basically I is going up 1 each time. And so as I go across my canvas, I'm just multiplying the width of one building by the number that we're counting. And that gives me the starting position of that building. So to start, let's draw a rectangle. So I'll draw a rectangle at x, and I'll just start it in the middle. So I'll start it at 100. And we will go x plus w. So we're adding the width of the building to the beginning of the building. X plus w, and then we'll make it 200 height. So there we have our basic buildings. So now I want to vary a couple things. So first I'm going to turn off the stroke. And then for the fill, I'm just going to do a random value in grayscale, so that's pretty easy. I can just say fill random 255. It's going to give me a 1 number, so it's just going to be a random gray color. So that works pretty well for the buildings, although I don't really want like a fully white building. So let's do like 100 to 255. Oh no, that's the wrong direction. Let's just do random 200. So then we want a random height. So I'm going to say let h equals, and so we'll vary the building somewhere between, let's say, 100 pixels and 250. So I can put the height in for the y value, and then that's where it's going to start. That's where the top of the building is. So we need to calculate what the bottom of the building will be. So that's going to be the height of the canvas minus the height of the building. So height minus h. Okay, so now we have some random different buildings, although they seem to be overlapping a bit. I wonder what's happening there. Did I put the wrong? Oh, I don't need to do x plus w. That's silly. I just need the width of each building. Okay, so now I have some buildings with random heights. Some of them are too short, so I'm going to just do 150 to 250. Oh no, but that's also the opposite direction. It's kind of tricky. So this is really not h, this is really y. Shouldn't have put h there. So y is really where the building starts. So let's do 50 to 150. And then h, let's calculate it up here, is the height of the canvas minus where the building starts, which is y. So that'll be a little bit simpler. They still seem kind of short. Let's do 50 to 100. Did I put, oh, I still have h here. There we go. Okay, so let's do 50 to 150. Okay, cool. So now I have some buildings. So I could do more variations like the width, but I kind of like that they're all the same width. But so now here's where it's going to get crazy. I'm going to put a grid inside of each building. So now I have these dimensions for the building, x, y, width, and height. And so now what I'm going to do is a nested for loop inside of each building. So I'm going to make some windows inside of each of these buildings that match the parameters of the building. So here is where I might think I better create a building function because this is going to get really confusing. So let's make a new function, call it building, and it takes the same parameters as our rectangle. So I'm just going to copy those here, x, y, width, and height. And then I'm just going to replace this rectangle with building, or actually let's copy it first. Let's put our whole drawing code in here. And then just replace rectangle with building. So this code is much nicer to read now. We have this one pattern function that decides the number of buildings and calculates the width, x, y, and height of each building. And then we have a different function that actually draws the building. So this is going to look a lot nicer. Let's tidy up the code. And so now we got to draw our windows. So now for each building, we're going to have a for loop. So we're going to say for let x equals 0. Although we can't use x because we already have an x here. So let's use underscore x equals 0. Underscore x is less than w. That's just the width of the building. And then now we have to calculate how many windows we want and how big they are. So let's say we want num windows. So let's say somewhere between 2 and 4. So we'll say floor random 2 to 4. And so the width of a window, so let's use underscore w for that. The width of a window is the width of the building divided by the number of windows. So now we have x, meaning where we're starting drawing our windows, underscore x, and then the width is the width of the building, and then we're going to say underscore x plus equals underscore w. So the underscore x stuff might be kind of confusing. If you want to write this more specifically, you could also say something like window width. That might be a little bit easier to understand. It takes up more space, so I like to use shortcuts, but we can put a little note here, window width. So we're starting at 0, although we don't actually want to start right at the edge of the building. So let's start at, let's calculate, okay, so if we have between 2 and 4 windows, we also need the gaps in between the windows. It's a little more complicated. So we can start at underscore w divided by, or let's just start at underscore w. So one width of a window will go in. And let's see how that works. We'll fix it later. So then we need to know, so that's actually the columns of the windows. That's how many windows across. So then we need to know how many rows of windows. So I'll say window columns. And then we'll say let window rows floor random. Let's do at least 3 to 5 rows of windows for each building. So then the height of each window row is the window rows number divided by h, the height of our building. Okay, so now we can set up our while loop. So we'll say for let underscore y equals underscore h, then underscore y is less than height, the height of the whole building, then underscore y plus equals underscore h. So we have our whole grid inside of our building. And now we can just draw a rectangle. Let's change the fill to white, so it'll stand out a little bit, and just draw a rectangle, underscore x, underscore y, underscore w, underscore h. And we're gonna have to adjust a few things, but this will get us close. Uh-oh. What did we miss? We've got all our windows in one place. Okay, I must have missed something along the way. Or maybe there's an error. No errors. Oh, you know what? I can't set x to width. I have to set x to the x of the building plus the width, y of the building plus the height. Okay, now I'm getting... oh, then I have to keep using this. So as long as x is less than... I think I missed something somewhere because this shouldn't be as complicated. So y starts at the x plus, let's just start at x and y. And until x is less than say x plus w. That might be what we're missing. Y plus w. I think they're just really tiny. Okay, let's log these values and see what's going on, because this is doing something weird. Underscore x, underscore y. And so I'll look at the xy of each building and then the xy of each window and just log those. And there's definitely too many of them because this is taking forever. Okay, let's start it over. Let's start from scratch. So let's just delete this. And let's just do some tests. So let's fill in white and let's just draw one window. So I'll draw a rectangle at x, y, and we'll do underscore w and underscore h for the width and height of the window. Okay, so that doesn't even work. Sorry guys, I don't know which part I missed. Let's log those values and see what they are. So x is 0, 120, 240, 360. That makes sense. Y, those all make sense. And then the width and the height are just really, really small. Okay, so that's the problem. So let's compare. So the number, so width, the number of windows, and then the resulting width of the window, that makes sense. Okay, then the same thing, the height of the building, the number of window rows, the height of each row. There we go, I switched these. Whoops, okay. H divided by window rows. So I just divided the wrong thing, so maybe I should be using better variable names. Okay, so there's our first window. So let's divide the width of the window by 2 so we have some more space, the height of the window by 2. And let's add width over 2 to the beginning and height over 2. Okay, that's a little bit better. Now let's add in our loop. So for let underscore x, we'll start at x of the building. As long as underscore x is less than the x of the building plus the width of the building, x plus w, we will add the width of our window to the x of the window. For let underscore y equals y of the building, underscore y keeps going as long as it's less than the y of the building plus the height of the building, and then we add the window y to the window height. So now let's take our rectangle, and we just have to replace these. So this is now the window x, and this is now the window y. Okay, now it's broken again. Okay, now I killed the browser. All right, let's try it one more time. Sorry, I keep screwing this up, but it's almost done. So let's try it one more time. So this has to be h divided by window rows. So now we're going to say for let underscore x equals x as long as underscore x is less than x plus w, underscore x plus equals underscore w. So let's just put in our window here. Try it one bit at a time. Okay. Let's divide our window size in half and move them over a little bit. Okay, and move them down a little bit. Okay, we're getting somewhere. So now we can add in our while loop for let underscore y equals y, underscore y is less than y plus h, underscore y plus equals underscore h. And just replace the underscore y. There we go. Okay, so now we have some windows, and let's do over 4 here, and that'll fix that. Okay, sorry about that. Usually that goes a little more smoothly. But the main point here is to see that we can kind of nest these structures within each other. So we have our function for our main pattern, and that decides how many buildings we want and how to draw the buildings. Then our building function is going to decide, it's going to draw the background of the building and then decide our windows and set up our windows. And if we want to get even more complicated, we can create a window function. So we can keep going. I can make a function for the window. And if I want to make my window more complex, now I can just use x, y, width, and height for the window. So these values are really complicated because I had to do all this math to figure out where the window should go. But once I figured those out, I don't have to keep using them. So if I want to have a better time designing my windows, I can come down here and just draw rect at x, y, width, and height. Oh boy. Now, oh, there's a window function in P5. Okay, let's just call this win for window. I think that's why it's crashing. There we go. Okay, so we'll use win for window. So now I have a window function that just uses x, y, width, and height. And so now I can use that to design the rest of my window. I don't have to use all these gnarly lines that I had to figure out up here. So for example, if I want to put some lines in my window, I could say line from x to starting at y plus height over 2, so middle of the window, to x plus w, so moving over to the other side of the window, and same y plus height over 2. And we got to put on a stroke, so we'll say stroke is black. And so now I have a window with some lines. And if I want to go really crazy, this is the last one I'm going to do, I can use a loop in here. So let's say for let underscore x equals, for this one, let's say we want to add lines to the insides of the window going across. So I'll just do one for loop. I won't do a nested for loop here. So I'll say let x equals x plus, let's do width over 4. X is less than x plus width. X plus equals width over 4. So this should draw a few lines. So now I'll draw a line at underscore x. Oh, and I got to make sure that these x's are the underscores. So a line at underscore x from 0, the top, or from y, the top of the window, to underscore x stays the same, and then y plus h, the bottom of the window. And now I have some vertical bars to go along with my horizontal bars. So this probably looks a little crazy, but if we tried to do that within one for loop, it would be, you know, this inside of this inside of this. So figuring all this out, obviously it was a little more challenging than I remembered, but the main point is the advantage of using these separate functions is that we can take some stuff here that looks pretty nuts, but then bring it down here and have something that looks pretty simple again with just our few basic arguments. Okay, sorry, that took longer than I expected it to. I'm going to stop here.